Today we are focusing on factors of numbers, and in specific, the greatest common factor of two sets of numbers. So how can we find the greatest common factor of a number? This is our question. We have a pet store that sells both goldfish and angelfish, and they have to be put in the fewest number of glass containers. But the thing is, every container has to contain the same number of fish, and each of them has to contain either all goldfish or all angelfish. So today it's going to be very easy for me to recognize those of you who know your math facts and who remember some of those divisibility rules that we learned a while back. We know that the number 20 and the number 30 are not prime numbers. Prime numbers are only 1 times themselves. We know that 20 and 30 are composite numbers. The reason we know that is because they're both what type of a number? Even. Good job, Darius. So if we want to find the greatest common factor of these to help us solve our problem, I'm going to teach you a strategy today. Finding a number that is a factor of both of them is called a common factor. But our goal today is to find the greatest common factor, the biggest number that will go into both of those. That's going to help us do better at finding equal fractions. Okay, let's move on here. So the common factors of 20 and 30. Now they listed them out for you, but I want to show you guys a way that is, in my mind, a surefire way to make sure you list all of them. So I'm going to start with the number 20. Okay? I'm going to box it. All numbers can be multiplied by 1 times itself, right? That's a factor pair. 1 times 20 gives you 20. Now let's move down the line to the number 2. Would 2 go into 20? We know that because it's an even number. 2 times what? 10. Good. Now let's keep moving. 3? The divisibility rule for 3s is if you add up the digits and 3 goes into that, it'll work. Will it? No. How about 4? Yes. 4 times what gives us 20? 4 times 5. Now, as I go around here, this is called the wraparound strategy. There are no numbers between 4 and 5. So I know this is it. This is all there is. If I look down here to what this guy did when he made this problem, it's the same list. Okay? Now let's go on to 30. I'm going to do it this way. We always start with 1 times 30. Is it an even number? Yes. So 2 times what? 15. Will 3 work? Yes. 3 times? 10. Will 4 work? Yes. No. Will 5 work? Yes. There's no numbers between 5 and 6. These numbers continue to get larger. We're done. Well, we're partway done. We have all the factors of 20, all the factors of 30. Now, out of those, which ones do they both have in common? Give me one example of something they have that's in common. Emma? They both have a 1 and they both have a 2. Is that it? No. Is there more? 5. They both have a 5. You're right. Anything else? Will? They're both whole numbers. Okay, but we want to know factors that they have in common. Oh, they both have 10s. They do both have 10s. Is there anything else? So now it's our job to find the greatest common factor. What is the number, the largest number, the greatest number that they have both in common? Aaron? 10. So the greatest common factor of 20 and 30 is the number 10. That's what we're going to focus on today. That's what we're going to do. The next problem we're going to do together just on the board. I'll tell you, this thing's a little bit fussy today. We're going to start easy with the number 9 and the number 12. Let's start with the 9. We can always start with 1 times itself. How about 2? Yep. It's not even, no. How about 3? Yes. 3 times what? 3. Oh, well, we're done. We know we're done because there's no numbers that fit between a 3 and a 3. So I'm going to wrap it up. We're done. Let's go to the number 12. We always start with 1 times itself. What about 2? Will 2 work, America? 2 times what? Okay. How about the number 3? Will 3 work? 3 times what? Now, there's nothing between 3 and 4, so I can wrap it up. I'm done. What are the numbers they both have in common? Give me all the numbers that they both have in common. Dathan? They both have a 1. They both have a 3. Is that it? So now, what is the greatest common factor? The greatest number that they both have in common? Aaron? It is. It's 3. That's it. Today, when you do your practice, I would give you 1 full point if you had all the factors of 9. I'd give you a 2nd point if you had all the factors of 12, and I'd give you a 3rd point if you chose the right greatest common factor. So most of your work today will be worth 3 points. All right, I'd like you to pull out your iPads. Now you'll have to write a bit smaller today. Our first example that you are doing is 20 and 45. I think we're going to start with the 20. Now, for those of you who are really paying attention, this one's going to be a piece of cake because we already used the number 20 in a previous problem. Go ahead, make your list. Don't even look up at the board until you're done, then check it with mine. As our numbers get larger, they get a little bit tougher. Double check your 20 and see if you have all the ones that I have, and then move on to 45. It's not an even number, so 2 isn't going to work. What about 3? Now, how many of you are stopped right here? Because you can't for the life of you figure out 3 times what gives me 45. Is anybody stumped? Okay, here's what you could do then. You could try down here, 45 divided by 3. How many 3's are there in 45? Dathan, do you know? There are 15. Let's move on to 4. Will 4 work? Nope. How about 5? Will 5 work? Yes. Yep, there's a divisibility rule. 5 times 9. So now all we have left to try is a 6, a 7, and an 8, because those are the numbers left between 5 and 9. Will any of those work? None. We are done. Now that we have both of those numbers wrapped up, what is the greatest common factor that they both have in common? Aiden? 1. There's something bigger than 1. 1 is a common factor, but it's not the greatest common factor. Do you see it? 5. The greatest common factor is 5. Okay. I'd like you to go to a new screen. And I'm going to actually pause the smartboard as I give you the next one. So those of us who are working, if you're working at home, we're going to do 7 and 28. I'll give you some time. Aaron, will you give me the rest of the fraction pairs for, yep, for 28? Uh-huh. Is that it? Okay, so this one's wrapped up. This one's wrapped up. That means the greatest common factor is 7. How'd you do? Excellent. Now, you're probably thinking, these are a piece of cake, and pretty much they are, but we're going to get a little bit tougher. Just a little bit tougher. Here's the next one. 18 and 32. Give me the factor pairs of 18. Darius? Excellent. Good work. Wrapped up and done. How about the factor pairs for 32? Sky? That's it, right? Done. Okay. Now, my greatest common factor, the biggest number they both have in common is what? Aaron? That's it. It's just a 2. You would think that it would be something bigger, but it's not. Okay. Is it possible that 2 numbers could have a greatest common factor of 1? Yes. Give me 2 numbers that would have a greatest common factor of 1.
1 and 7.
Okay, well, okay. 2 and 7, okay. I just didn't like the number 1 so well. Anything else that's prime, right? 7's a prime number. Give me another prime number. Yell it out.
1.
3.
1.
I just don't love 1s because 1 times 1 is 1 and it doesn't give any variation really. Dathan? 5. 17. 13. Good work. Okay, our last example before you get started today. $15 and $35. Surprisingly enough, this shouldn't take you very long. Who wants to share the factor pairs of 15? Sky? Good work. There's nothing between 3 and 5 than a 4, only a 4, and we know 4 won't work, so we can wrap this one up. How about 35? Sam F? Yep. What else? That's right. The only number between them is a 6, and we know 6 won't work, so we're done. We can wrap it up. What is the greatest common factor of 15 and 35? Emma?
5.
It's a 5. How many of you thought you could have maybe, possibly done that one in your head just by really thinking about it? Good. Good work.